Hello students, hope you are doing well. In this video, we are going to discuss Network Management Protocol and Features Part 1 of Unit 2, Structuring and Modularizing the Network for the subject Enterprise Network Design of B7 Semester IT University of Mumbai. In this lecture, we are going to discuss Network Management Protocol and Feature. Proper network management is a critical component of an efficient network. Network administrators need tools to monitor the functionality of the network devices, the connections between them, and services they provide. SNMP has become the de facto standard for use in network management solution, and it is tightly connected with the remote monitoring RMON and Management Information Base MIB. Each managed device in the network has several variables that quantify the state of the device. You can monitor managed device by reading the value of these variables, and you can control managed device by writing values into these variables. So in this particular lecture, this is divided into part 1 and part 2. In part 1, we will cover network management architecture, protocols and standard, SNMP version 1, version 2 and version 3, MIB, MIB2, Cisco MIB, the MIB polling guidelines and MIB examples. And remaining portion will be discussed in part 2. Network management architecture. This diagram shows generic network management architecture. In this generic management architecture, there are network management applications, managed devices like router, etc., and different management protocol and standards like SNMP, MIB, and RMON. So initially we start with network management system. What is that? A system that executes application that monitor and control managed devices, all these managed devices. Network management systems provide bulk of the processing and memory resources that are required for network management. Now come to network management protocols. So these are the network management protocols and standard. These protocols facilitates the exchange of management information between NMS and the managed devices, different managed devices, including the SNMP, MIB, and RMON. Managed devices are devices such as routers are there, managed by NMS. Then management agents, software on managed devices. The software present on these management devices that collects and store management information including SNMP agents and RMON agents. Now come to management information. Data that is of interest to a device management usually stored in MIBs, different MIBs. So what is the full form of MIB? Management Information Base. Protocols and standards. A variety of network management application can be used on a network management system. The choices depends on the network platform, such as the hardware operating system. The management information resides on the network devices. Management agent that reside on the devices collect and store data and standardize data definition structure known as MIB. The network management application uses SNMP or other network management protocol to retrieve the data that the management agent collects. The retrieved data is typically processed and prepared for display with a GUI, which allows the operator to use graphical representation of the network to control, manage devices and programs that network management application. So initially we start with this protocols and standard. So there are several protocols, okay, that use within the network management architecture. So initially we start with SNMP. SNMP is a simple network management protocol. SNMP version 1 was extended to SNMP version 2 with its variants which were further extended with SNMP version 3. Now come to MIB. The MIB is detailed definition of the information on a network device and is accessible through a network management protocol such as SNMP. And then RMON is the extension of MIB. The MIB typically provides only static information about the managed devices. The RMON agent collects a specific group of statistics for long-term trend analysis. The ISO network management model defines 5 functional areas. These include fault management, configuration management, account management, performance management, and security management. So FCAPS, this is FCAPS. Okay. So the FCAPS model and these functional areas are rarely implemented in a single enterprise-wide network management system. A typical enterprise uses a variety of network infrastructure and service elements managed by the element-specific network management system. So this is the protocol and standard. Simple network management protocol. Simple network management protocol. What is that? Let us see. SNMP has become the de facto standard for network management. It is a simple solution that requires little code to implement, which enables vendor to easily build SNMP agent for their products. In addition, SNMP is often the foundation of the network management architecture. SNMP defines how management information is extended between network management, application, and management agents. So this diagram shows a pictorial representation of how SNMP works. So this is manager, manage device agents and MIB, and SNMP protocol for message exchange. So let us discuss each component one by one. So first is manager. The manager, a network management application is it is in an NMS, periodically polls the SNMP agents that resides on the managed devices for data, thereby enabling information to display using a graphical user interface as on the NMS. The disadvantage of periodic SNMP polling is the possible delay between when an event occurs and when it is collected by the NMS. There is a trade-off between polling frequency and bandwidth uses. So two things, polling frequency and bandwidth uses. Very important thing, whenever we are using polling, it requires a large amount of processing overhead. Therefore, this delay is coming. Now come to protocol. Second is protocol. So SNMP is a protocol for message action. It uses user datagram protocol transport mechanism to send and receive the management information such as MIB variable. Okay, such as MIB variable. Then third is manage devices. First is manager, second is protocol, third is manage devices. Devices such as router managed by the manager. Next is management agent. So SNMP management agent resides on managed devices to collect and store a range of information about the device and its operation, respond to managers' requests and generated traps to inform the manager about certain events. So these are the traps which inform manager about certain events occur. SNMP traps are sent by management agent to the NMS when certain event occur. Trap notification could result in substantial network and agent resource saving by eliminating the need for some SNMP polling request. Okay, so this is SNMP polling request. Now MIB. MIB is not written here. Okay, this is MIB. The management agent collects data and store it locally in the MIB, a database of objects about the device. Community strings, which are similar to passwords, control access to MIB to access set MIB variables. The user must specify appropriate read or write community string, otherwise the access is denied. Okay, so this is SNMP. SNMP SNMP version 1. SNMP version 1, the initial version of SNMP, SNMP version 1 is defined in RFC 1157. RFC 1157. What is that RFC? RFC is request for comment document. Request for comment document. Simple network management protocol. The protocol simplicity is apparent by the set of operations that are available. It is shown in this figure. It is blank, and this particular portion shows communication between manager and managed device and agent and MIB. Okay, so how this thing happen? Let us see one by one. So here we start with get request, used by the manager to request a specific MIB variable from the agent. Now get next request, use after the initial get request to retrieve the next object instance from the table or list. Then come to set request, used to set a MIB variable on the agent. Then get response contains values of requested variable used by the agent to respond to a manager's get request or get next request message. Okay, and then finally come to trap used by an agent to transmit an unsolicited alarm to the manager. A trap message is sent when a specific condition occurs, such as a change in the state of device, a device or component failure, or an agent initialization restart. So this is how SNMP work. SNMP version 2. It is a revised protocol that includes performance and manager to manager communication improvement to SNMP. SNMP version 2 was introduced with RFC 1441. RFC 1441 Introduction to version 2 of the Internet Standard Network Management Framework. But members of IETF subcommittee could not agree on several sections of SNMP version 2 specification, primarily the protocol's security and administrative needs. So in this respect, several attempts to achieve acceptance of SNMP2 have been made by releasing experimental modified version commonly known as SNMP version 2, SNMP v2, SNMP v2u, SNMP 1 plus, and SNMP v1.5, which do not contain the disputed parts. Community-based SNMP version 2 or SNMP version 2C, which is defined in RFC 1901. Okay, original was 1441, and this is RFC 1901 Introduction to Community-based SNMP Protocol version 2. It is referred to as SNMP v2 because it is the most common implementation, and the C stand for community-based security because SNMP version 2 C uses the same. So there are two new type of messages is included in SNMP version 2. Community string as SNMP version 1 for read and write access. As a SNMP v2 changes include the introduction of these two new message type. First is get bulk message type and inform request. So get bulk message type use retrieving large amount of data. large amount of data such as tables. This message reduces repetitive requests and replies, thereby improving the performance. Now come to inform request. Used to alert SNMP manager of a specific condition. Unlike unacknowledged trap messages, informed request messages are acknowledged. A managed device sends an informed request to the NMS. The NMS acknowledges the receipt of the manager messages by sending a response message back to the managed device. One more improvement of SNMP version 2 over SNMP version was is the addition of new data type. That is the addition of new data type with 64-bit length, and this is counter. Okay, counter. Why it is used this 64-bit? Because 32-bit counters were quickly overflow, okay, by the fast network interface. That 32-bit counter is quickly overflow. So on Cisco router, Cisco iOS software release 11.3 and later version implement SNMP version 2. However, neither SNMP version 1 or SNMP version 2 offers security features. Specifically, SNMP v1 and SNMP v2 can neither authenticate the source of management message nor encrypt the message. So these are the shortcomings of SNMP version 2. So because of lack of these security features, many SNMP version 1 and 2 implementations are limited to read-only capability, reducing their usefulness to that of network monitor. So due to the shortcomings of SNMP version 2, SNMP version 3 is coming into existence. This is the latest SNMP version to become full standard. Its introduction has moved SNMP 1 and SNMP 2 to historic status. SNMP version 3, which is described in RFC 3410. RFC 3410. This is the standard through 3415. 3415, 10, 11, 12, 13, 14. These are the SNMP standard, SNMP version 3 standard. Okay. So, which it adds method to ensure the secure transmission of critical data to and from managed devices. So here we can see that 3410 is for introduction and applicability of statement of internet standard management. Then 3411 is an architecture for describing simple network management protocol management frameworks. This is for framework and this is introduction. Then 3412 message processing and dispatching, send and receive, processing and dispatching for the SNMP. Then different SNMP applications are there in 3413, RFC 3413. In 3414, user-based security model USM for version 3 of the SNMP version 3. Then 3415 view based access control model VACM for SNMP. Okay, so these are the SNMPs. To overcome shortcomings of SNMP version 2, SNMP v3 is coming, and there are three different security levels provided by SNMP v3. So these are no auth, no prep, auth, no prep, auth prep. What is the meaning of that? Okay, no auth means no authentication and no prep means no privacy. So we can very easily write the things authentication and privacy. Now you can guess auth no prep means authentication is there but privacy is not there. Here authentication and privacy both are there. Okay, so this is how without authentication and without privacy or encryption is provided with no auth, no PRIV. So we can, how do we implement different methodology? If we see that it is provided with authentication, then there are two different protocols: hash based message authentication code message digest 5 HMAC protocol, and secure hash algorithm protocol. With privacy with authentication in auth PRIV, 56-bit cipher block chaining data encryption, standard encryption standard. So this is DES and SES. Okay. So these are the things associated with SNMP version 3. Security levels can be simplified per user or per group of users via direct interaction with the managed devices or via SNMP operation. Security levels determine which SNMP object a user can access for reading, writing, or creating, and the list of notification that user can receive on Cisco router. Cisco iOS software release 12.0 and later version implement SNMP version 3. Okay, so this is iOS, Cisco iOS 12.0 or later. Management Information Base or MIB. This is a collection of managed object. MIB store information which is collected by the local management agent and managed devices for retrieval by a network management protocol. Each object in MIB has unique identifier that network management application use to identify and retrieve the value of a specific object. Here you can see in this tree diagram. This MIB is tree-like structure, which is similar objects are grouped under the same branch of MIB tree. Like different interface counters are grouped under the MIB trees interface. Okay. So in this particular figure, the MIB structure is logically represented by tree hierarchy, and the root of tree is unnamed. Right? And it is split into three main branches. ISO 1, CCITT, and joint ISO CCITT2. So here some number is there, 1, 2, okay, and in this diagram CCITT it is written. So this number is D or maybe 0. It may be misprinted in book also. So what is the full form of CCITT? This is Consultative Committee for International Telegraph and Telephone. ISO is International Standard Organization, and joint ISO and CCITT. These branches and those that fall below each category are identified with short text strings and integer. So this is divided into two parts. Like ISO is divided into two parts. Here ISO is a string and one is the integer. So now come to text string describe object name. So this particular string describes the object name, whereas integer form object identifier. So this integer forms object identifiers that allows software to create compact encoded representation of the name. The object identifier in the internet MIB hierarchy is the sequence of numeric label on the nodes along a path from the root to object. The internet standard MIB is represented by the object identifier 1.3.6.1.2.1, which can be expressed as ISO 3 is org, 6 is DOD, Department of Defense, then 1 is again ISO. Okay, so for this one we use internet. Okay, one more internet. Then 2 is management. Then again 1 is MIB. How this is coming? We go layer by layer. 1.3, 1.3, 1.3, 3.6, 6.1, 1.2, 2.1. Okay, 1.3, 0.6, 0.1, 0.2, 0.1. This is the way. So how this is represented, you can easily do this. Standard MIBs are defined in various RFCs. For example, RFC 1213 Management Information Base for network management of TCP IP based internets. MIB2 defines the TCP IP MIB. In addition to standard MIBs, vendor can obtain their own branch of MIB subtree and create custom managed objects under that branch. A Cisco router MIB uses both standard and private managed objects. There are different things. MIB contains several defined standard managed by the object in interface group, including interface description, type, physical address, counts of incoming, outgoing packet, and so forth. So this is interface group. Okay. Now come to IP group. It includes whether the device is acting as an IP gateway, the number of input packets, the number of packets discarded because of error, and so forth. Next is ICMP group, that is protocol. Okay, including the number of ICMP messages received, the number of message with errors, and so forth. So this is how we can use, and this is a standard manage object. Now come to private section of the MIB tree. This contains private managed objects like buffers, small buffer, medium buffer, large buffer, or huge buffer, like memory, whether it is primary memory or secondary memory, and some proprietary protocols. So private definition of managed object must be compiled into the NMS before they can be used. The result is output that is more descriptive with variable and events that can be referred by the name. Now come to, this is structure of MIB2, and this MIB2 is uh, located in RFC 1213, and this is the extension of original MIB, which is now called as MIB1 and is defined by RFC 1213. So what is that? It supports a number of new protocol and provide more detailed structure information. It remains compatible with the previous version, which is why MIB2 returns same object identifier as MIB1. So this is not tree diagram, but here different numbering is shown, like system, interface, address translation, IP, ICMP, TCP, UDP, BGP, transmission, SNMP. So these are the 11 group. Okay. Although the MIB2 definition is an improvement over MIB1, the following things are unresolved issues. Like MIB2 is still a device-centric solution. That means that its focus is on individual device, not the entire network or data flow. It is pole-based, meaning that data is stored in managed device and management system must request pole it via the management protocol. The data is not sent automatically. What is polling? I already told that we send a request. Okay, send a request, then it will receive the output, and so many times until the device is available. And this type of blocking cause processing overhead. Okay, and therefore it is a result in delay. Fine. Now come to Cisco MIB. So the Cisco private MIB definitions are under Cisco MIB subtree 1.3.6.1.4.19, or one is ISO org DoD Internet Private Enterprise Cisco. Okay, So this is the number, and by this number you can get the exact extension. Cisco MIB definition supported on Cisco devices. These are available at cisco.com/public/MIBs. Now, the Cisco private MIB subtree contains three subtree: local, temporary, and Cisco management. The local two subtree contains MIB object defined before Cisco ISO software release 10.2. These MIB objects are implemented in SNMP version 1 structure of management information. The SMI, this is structure of management information, defines the structure of data that resides within MIB managed object. Beginning with Cisco iOS software release 10.2, however, Cisco MIBs are defined according to the SNMP version 2. SMI are placed in the Cisco management subtree 9. The variables in the temporary subtree are subject to change for each Cisco iOS software. So here it is written Cisco management 9. Okay. Now come to polling guideline. What are the things associated with polling? Monitoring network using SNMP require that the NMS poll each managed device on periodic basis to determine its status. Frequently polling many devices or MIB variable on a device across a network to a central NMS might result in performance issue. Okay, including congestion or slower links or at the NMS connection or overwhelming the NMS resources when processing all the collected data. So there are recommended guidelines. First is restrict polling to only those MIB variables necessary for analysis. Analyze and use the data collected. Do not collect data if it is not analyzed. Okay, so analysis is must. Increase polling intervals. Polling interval must be increased. In other words, reduce the number of polls per period over low bandwidth links. Leverage non-polling mechanisms such as SNMP, Trap, Harmon, and Syslog. Track really works well. Instead of polling, Trap works well. For larger network, consider deploying management domains, a distributed model for deploying an NMS. Management domain permit polling to be more local to the managed devices. As a result, they reduce overall management traffic across the network and the potential for one failed device or link to interrupt management visibility to the remaining uh, network. So this is how polling is done. Now come to examples of MIB. So this is manager and SNMP get request and object identifier is 1.3.6.1.2.1.2.2.1.0 etc. So what is the meaning of that? How this manager understands? So base format to retrieve the number of errors on interfaces ISO org DOD internet MGMT MIB interface if table if entry if out errors. If out errors for this 20 is the number. Specific format to retrieve. This is to retrieve the number of errors and this is to retrieve the number of errors on first interface. On on particular interface or any interface or for first interface 13612122120 and this is the instance. Okay, here instance is not present, otherwise everything is there. So in this example, the network manager wants to retrieve the number of errors on the first interface. How do you come to know? Because in case of first interface, 20.0 is written. Okay, so this 25.0 shows first interface. Next is starting with the interface number 0. The valid range for interface number 0 through the maximum number of ports -1. The manager creates SNMP get request message with reference to MIB variable, this MIB variable, okay, which represent interfacing Outgoing errors on the interface 0. The agent creates SNMP get response message to response to the manager's request. The response includes values of the reference variable. In this particular problem, the agent return value is 11. So here it is 11. Okay. Outgoing error on the interface. So with this, the MIB is also in this chapter or lecture. We have completed network management architecture, protocol and standard, SNMP version 1, 2, and 3, MIB 2, Cisco MIB and MIB polling guidelines, and MIB example 1.2.3, etc. This we finish network management protocol and features part 1, and we will come with part 2 in next video. Thank you very much.